Hi, I am Syed on Maths Online. In the previous video, we have discussed about finding out the particular integral of the form e power of ax. Today, we'll try to discuss about the particular integral of the form sin ax or cos ax. So this is of type 2. This particular integral of the form 1 by f of d square into sine of ax and 1 by f of d square into cos ax. For sin ax and cos ax, the procedure for finding out the particular integral is the same. So let me take for example sin ax. So that will also be true for cos ax. So particular integral of 1 by f of d square times of sin ax. So whenever you have the trigonometric function sin ax or cos ax, we'll adopt this procedure. So what we are going to do over here is we'll try to replace the value of d square by minus of a square. So replace the value of d square by minus of a square. So this will be equals to 1 by f of minus of a square into sine of ax, provided that this denominator is not equals to 0. F of minus of a square is not equals to 0. In case if this denominator becomes equals to 0, we have to differentiate this denominator value as well as multiply by x. So if I take this as the equation number 1, so equation number 1 will imply, so you have to multiply by x and differentiate this denominator f dash of d square into sine of ax. So once again we'll try to replace the value of d square by minus of a square. So replace d square by minus of a square. So we get the value to be equals to x into 1 by f dash of minus of a square into sine of ax, provided that this denominator is not equals to 0. Suppose if this denominator becomes equals to 0, so once again you have to differentiate this one and multiply by x. So we'll be getting x square 1 by f double dash of d square into sine x. So this procedure will continue till this denominator becomes a non-zero term and so on. Now let us take few examples based on this form. Solve y double dash minus 4y dash plus 13y is equals to cos of 2x. So let us write down this in the form of the operator d square minus 4 times of d plus 13 times of y is equals to cos of 2x. So let us write down the auxiliary equation. The auxiliary equation will be m square minus of 4m plus 13 is equals to 0. So let us try to find out the roots of the equation by using the calci. The coefficient of m square over here is 1, coefficient of m is minus of 4 and the constant term is 13. So in your calci you can just press more, then choose the equation. So you have to use option number 3, then type the coefficients. So the coefficients that you have is 1. So press 1 equals 2, 2 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 equals 2, then you have minus 4 equals to, then you have 13 equals to, plus equals to, you will be getting the first root to be equals to 2 plus 3i. The next root will be 2 minus 3i. So complex roots you are getting. M will be equals to 2 plus r minus 3i. That's the root. So therefore the complementary function will be, so it is e power of 2 times of x into, it is c1 cos of 3 times of x plus c2 sine of 3 times of x. So that is the complementary function. Let us try to find out the particular integral. The particular integral will be 1 by the operator d square minus 4d plus 13 times of the right hand side value is cos 2x. So cos of 2x. So whether it is sine or cos, you have to replace the value of d square by minus a square. So according to the procedure, we have to replace the value of d square by minus of a square. So here a is nothing but the coefficient of x. Coefficient of x is 2. So you get the value as minus of 2 square. So minus of 2 square will be minus of 4. So we get the particular integral to be equals to 1 by d square value is minus of 4. So minus of 4 minus 4d plus 13 times of this cos of 2x. So this will be equals to, what is 1 by, so 13 minus of 4 will be 9. So 9 minus of 4d into cos of 2x. But still you have the operator in the denominator, but you have to replace d square. So you don't have d square. So to get that d square, we'll try to rationalize it. So rationalize the denominator. So rationalize the denominator. So that will be equals to, it is 1 by 9 minus of 4d. If you try to rationalize this term, it becomes 9 plus 4d divided by 9 plus 4d times of cos of 2x. This will be equals to 9 plus 4d, the numerator value as it is, whole divided by, the denominator is in the form of a minus b into a plus b, which will be a square minus of b square. So you get 9 square minus of 4d whole square times of cos of 2x. This will be equals to 9 plus 4d whole divided by 9 square will be 81 minus 4 square is 16 into d square times of cos of 2x. Now since you got the value as d square, so replace the value of d square by minus of a square, which is minus of a value is 2, so 2 square, you get minus of 4. So this will be equals to 9 plus 4d whole divided by 81 minus 16 times of minus of 4 times of cos of 2x. So this will be equals to, now the denominator, the operator d has been completely eliminated. You need to just simplify this one. Now the numerator will also be simplified. So just try to multiply this 9 with cos 2x. So 9 times of cos of 2x plus this 4d also you multiply by cos 2x. So 4d times of cos of 2x. It's whole divided by. So if you try to simplify this one, it is 81 minus of minus will become plus, 16 times of 4 will be 64. So this will be equals to 9 times of cos of 2x plus, that is 4 times of. So you have to differentiate this cos. Differentiation of cos will be minus sign. So you will be getting minus 2 sine 2x whole divided by 81 plus 64 will be 145. Or further, if you try to simplify, you have 9 cos 2x. Here plus into minus will be minus. 4 times of 2 is 8 into sine of 2x. So it is whole divided by 145. So this is the required PI. Now we'll try to write down the final solution. Therefore, the solution is y is equals to CF plus PI. Therefore, y will be equals to CF value is e power of 2x into it is C1 cos of 3x plus C2 sine of 3x plus the particular integral that we have got is 9 times of cos 2x minus 8 times of sine 2x whole divided by 145. So that's the required solution.